Hi guys, and welcome to the video on measures of center and variance. So for this video guys, we're going to be learning to calculate the mean, median, mode, and standard deviation. These four things make up the most recognized and important details for a data set, and that's why we're learning this. And you'll know you're successful when you can calculate the mean, the median, and mode, and the standard deviation using a graphing calculator. So, reading dot plots is the first thing that we need to understand for this section. A dot plot is a statistical graph in which each value in the sample is plotted above a number line. The dot plot for some fuel economy random sample for 2015 model year vehicles looks like this. So if I have the dot plot of a data set, I can find the median or the mode by noting that each dot counts as one of the data value spot that it is on. In the graph above, there are 6 vehicles that get 31 miles to the gallon, and there are 6 dots there. This would also mean that in this case, that bar would mean that 31 miles per gallon is the mode. I could then enter all this data into my list, my graphing calculator screen, and then I could go ahead and have the calculator calculate the rest of the stats for me, the median and the mode, or the median and the mean here. But just so that we remember, the mean is the arithmetic average. You can add all of the data values together and then divide by how many data values there are. For the median, the middle number of an organized data set. So you order the numbers from least to greatest and then look for the number in the middle. If there are 2 numbers in the middle, like you're going to cross out the numbers on each end, if there are 2 numbers in the middle, then you need to take their average. And then the mode is simply the most repeated number in a data set. So examples of average problems. So I'm just going to work them out for you, and then you can go ahead and get them down here. So John caught 14 fish after a long day of fishing. After weighing all of them together, he calculated the average weight of them to be 4.7 pounds. What is the total weight in pounds of the fish? So essentially, this is asking us what was the total of the 14 fish. And so what I can do is take the average that I have, the 4.7. Excuse me, my point got a little high up. So 4.7, and I'm going to multiply it by the number of data points, 14, and that will give me the total that I used to have here. So this will be the total. So if I go ahead and multiply 4.7 times 14, that gives me 65.8 pounds. So basically, it's saying that when I took the 14 fish and added up their weights, I got 65.8, and then divided by the 14, and that left me with the average. So I kind of like just reversed the problem. All right, this next one. Throughout the year, Janet took 8 math tests. Her average score was an 83. If her average score after the first 5 tests was an 89, what was the average of her last 3 tests? So what we're going to have to do is first calculate how many points she scored on those 8 math tests. So we're going to do 8 times, that's a bad 8. We're going to do 8 times 83. We're going to do the 8 times 83. Pardon the screen buff there. Hit the wrong button. 8 times 83. And when we do that, 8 times 83 is 664. So to achieve that 83 math score, or 83 score, she had to have scored 664 points on those 8 tests. So if the first 5, we're going to do the first 5 here. So first 5, and then we're going to do the last 3 separately. The first 5 times 89, because the first 5, if her average score after the first, I know it says first 3 5 tests, excuse me, but it's first 5 tests, 5 times 89 is 445. So she scored 445 of those points on the first 5. So we're going to take 445 and subtract it from the 664. And that's going to tell us how many points she has left. So 219 points. So for the last 3, she has 219 points, and then she needs to divide that in among her 3 tests on average. So we'll take 219 and divide it by 3, and that means her average for the last 3 tests was a 73. She had 219 points to split between the 3 tests, means she had to score a 73 average on those tests. And then finally, another common average problem is if the average of 34, 44, 28, and x is 35, what is the value of x? So what you're going to do is you're going to go 34 plus 44 plus 28 plus x equals 35 on this side. Remembering that I still have to divide all of these by 4. So this just becomes a quick cross multiplication problem. So we're going to cross multiply here. And I get 35 times 4, so 140 equals, so if you add up 34 plus 44 plus 28, you get 106 plus x. You take away 106 from both sides, x has to be equal to 34. And that is the missing data value in this set. Okay, so that's just a couple examples of some average problems, guys. Let's take a look at some of the other things we're going to be taking a look at in this section. So, variation of data. There are 2 main measures of variation in data, quartiles and standard deviation. We use quartiles to determine outliers, and we plot these quartiles using a box plot. So what that means is on a number line, we would put some data points, we'd put in some markers, and we would have like a box plot here. Just a drawing, a quick one here, representing the median, quarter 1, the quarter 3, the median. The maximum is this dot on the end, and this minimum is the dot on this end. And that will show you how variated the data is. In the sense of, is it skewed towards the higher, like this data is skewed more towards the higher side, or is it skewed more towards the minimum side? And then we have a measure of variance called standard deviation. And standard deviation is a number used to tell how measurements for a group are spread out from the average. A low standard deviation compared to the average means that most of the numbers are very close, and then a high standard deviation would mean that the numbers are very spread out. So we're going to remember that because we're going to use those to talk about how spread out data is. So the greatest thing about all of this is that we can use a calculator to find all of these measures of center and variation, and I'm going to show you how. So, the stat menu. As you can see on my graphing calculator, if you press the stat key, the red button highlighted, that allows us to calculate a host of different statistics based on lists we provide the calculator. And if you go to edit, it will enter into our menus. So right here, I'm in the edit key, and then I would push 1 and go to edit. And I don't think, nope, just checking my scroll, don't have anything down there. You can enter data into L1 or L2, and we're going to stick by putting with putting data in L1 for now to allow your calculator to work with that data. So every time you enter a new piece of data, you'd write like 72, and then you would hit enter, and then you would hit like 65 and hit enter. And every time you do that, you're entering a new piece of data. And you have to enter all the pieces of data that you have. So if you have, like 20 different pieces of data, you have to enter all 20 numbers. The calculator menu. After you go back into stat, if you press the right arrow key on the calculator, as I showed, that will go ahead and it will bring up the calculator menu, the calculation menu, excuse me. That it brings up a variety of calculations your calculator can run for the list of statistics we provided. We're mostly going to use option 1, which is one variable statistics. So one variable statistics such as mean, median, mode, etc., etc. So it will look like this, okay? When you click the one variable stats thing, it's going to ask you what list do you want to go ahead and calculate the thing is. This should be, so this should be the list where you have your data. Should be the list where our data was entered. If it isn't, you're going to have to change it. And I typed entered wrong, excuse me. If it's not, you need to change it by highlighting it, and then you would click the second button, and then you would click L1. That button combination would put L1 back there. After you do that, you leave the frequency list alone, and then you hit enter. You go down to calculate and hit enter. What's going to happen is it's going to pull up a bunch of readout. It's going to pull out a readout like this. Okay, so what I did here is I took 4 numbers and I put it in my graphing calculator, or 7 numbers, excuse me. I put it in my graphing calculator, and then my calculator, I went to the one variable statistics, and it spit out this data. So here's what it all means for you. Okay, I'm going to scroll down a little bit so you can see both screens. If this button up here, the X with the line over it means the mean. So it's the average of the data set. So the average of the 7 numbers that I put in was 7. The sigma in front of X means that's the sum of the data set. So when you add all the numbers together, that's what they equal. The next one, the sigma X squared, you can ignore that. That doesn't matter for us. The capital S, X, means the sample standard deviation. And the population standard deviation is the little small sigma with an X. I will explain the difference between those in just a second. N stands for the number of data points. The minimum of X stands for the minimum of the data set. Q1 stands for where the first quartile is. Median stands for where the median, the second quartile is. Q3 stands for where the third quartile is. And the max is the highest number in the data set. So just going back, the sample and population standard deviation, I'm just going to check my next slide here. If the data you took, okay, which one of those standard deviations do I use? If you took data and that represents 100% of the population that you are making an inference about, then you use the population deviation. So population deviation was this one down here. So you're going to use this if you surveyed 100% of the everyone of the population. On the calculator, you're going to use sigma X if you did not survey 100% of people. Survey 100% of people. So examples of taking all of a survey population would be you survey all of the students in your high school class. That's totally possible. Or like the whole U.S. Senate. If surveyed, that would be 100% of a population, and you would use the little sigma X for the standard deviation. If the data represents a portion, you need to use sample. Examples would be taking a survey of 100 people in a city, collecting data on a couple houses in a neighborhood to estimate prices. So if you, like, for example, go and do the average prices for like 6 or 7 houses, and then you decide to make generalizations for all of the houses in a neighborhood, you would be using sample deviation. All right, so an example. A weatherman records a high temperature in Norfolk, Virginia for each of the first 7 days of the year. The temperatures in degrees Fahrenheit are 51, 49, 41, 53, 54, 68, and 48. Remember, guys, it's Virginia, so January can still be warm there. Calculate the measures of center and variation for that data set. So I'm going to pull down my screen here just to kind of show you what's going on calculator-wise. Okay, so I would be entering in my data like this, okay? 51, 49, 41, 40, 53, 54, 68, and 48. Afterwards, I'm going to go to the stat menu again. So this was me pushing the stat button. And then I went into edit. So I hit stat, and then I went to edit. And then I entered in the data. So enter data. And then Okay, I went ahead and I quit, or I pushed stat again. So for this, to get to this menu, I hit push stat, and then I push the right arrow key. And then I would have just selected option one variable statistics. Scrolling down here, and my one variable statistics showed me this. Okay, I've got a mean of 72. So calculate the measures of center. The mean here is 52 degrees. The median, excuse me, I had a serious brain fart. The median here would be 51 according to my calculator screen. And then the mode I would have to calculate myself by just looking at the data. So 51, 49, 41, 53, 54, 68, and 48. There is no mode since none of the data values are the same. Then finally, what I would do is I would put down my quartile markings. So I'm going to take this stuff to mark my quartiles. So the minimum is 41. Quartile 1 is 48. Quartile 2, which is the median, is 51. Quartile 3 is 54. And then the maximum is 68. So I can see that this data is kind of like with the median and quartile 1 being so much closer together, I can see that the data is definitely skewed towards the lower end. So this I would definitely say is skewed to the low end. And that's mainly because there's a 14-degree difference between the third quartile and the maximum, and there's only a 7-degree minimum or a difference between this and between quartile 1 and the minimum, and there's only a 10-degree difference between the minimum and the median, and there's a 17-degree difference between the quartile 2 and the maximum. And then finally, the standard deviation. These 7 days, okay, just represent a small portion of the year. So I'm going to use the sample. Okay, I need to use sample here because the 7 days does not represent all 365 days of the year. It simply represents 1 week, and that's not a whole data set. So what I will say is that the standard deviation is 8.25. Okay. Compared to the data, what I could use this standard deviation to say is that the 8.25 divided by 51, what I'm going to do is divide the standard deviation by the mean, and that percentage is going to tell me about how skewed, or how spread out my data is. So if I put 8.25 and divide it by 52, it's going to tell me about how spread out my data is. So 8.25 divided by 52 is around a 0.16, which means the data is relatively close together. If it was somewhere like a 0.4 or a 0.5, the data would be more spread out, but this 0.6 is about 16%. So we're talking that it's pretty relatively close together. So we would say it's closely spread. All right, and then the last one, a random selection of adults 18 to 31 were surveyed to find out how many hours they slept each night. Calculate the measures of center and variation for the results displayed in a dot plot below. So here I have my chart. I would have gone in and entered the data, so same way as before. So I would have used the stat and then the edit key. And then I would have done stat over to calculate, and then over to one variable stats. And then I've got my one variable stats down here. So then I can just go ahead and start listing off that the mean here was 8.57. Use 2 decimal places, guys. That's enough for rounding. The median was 9. And the mode was also going to be 9, since it was the stack that had the highest number of dots. I can go ahead and list quartile, or the minimum, the quartile 1, the maximum, all of those. So min, quartile 1, quartile 2, quartile 3, and the max. The minimum was 5, quartile 1 was 8, the median was 9, the quartile 3 was also 9, and the maximum was 12. And then that kind of tells me that the data is skewed towards the top. It's kind of actually more, or it's more centered. Now that I see that quartile 3 and quartile 2 are here, and it's like top towards the center, so center top skew, but I would still say it's more top skewed because you've got quartile 3 and the median at 9 compared to the maximum of 12, which is a difference of 3, and quartile 2 is 4 away from the minimum, which kind of makes it more skewed towards the top. This is an entire it's a random selection of adults 18 to 31, which makes it a sample. This is not an entire population. This is a sample because we did not survey every adult 18 to 31. So this is a sample. So we need to use the sample deviation, which means the sample standard deviation is 1.45. And if I compare the 1.45 sample deviation to the average, which is 8.57, I would get approximately 0.17 or 17%, which means this is still pretty relatively grouped close together. So this is a closely grouped data. And that's it, guys. So for this one, I'm really sorry this is a long video, but there's a lot to go over here. We calculate the measures of center and variation to describe data sets, and we're going to go over using that to build a box plot, the Q1 median, Q3 stuff, to build a box plot in class as well. Mainly, most of this work is done on our calculators. We're going to apply these ideas of averages too to help find missing parts of data sets accurately. And it's going to be a lot of calculator work on this one. So hopefully you got some good ideas with the screen grabs. Thanks for watching this video, guys. I know this was a long one. I appreciate you watching this one. So I will see you in the next one. Bye-bye.